Alright, so welcome everybody. Thank you guys so much for joining us for the Silverbacks Consistency Workshop. So this workshop is a collaboration between the three teams here, the Grillbots, the Silverwolves, and Team Tesseract. So we're calling ourselves the Silverbacks for this presentation because this group combines our team's collective experiences and lessons learned from one shared goal, building consistency in every aspect of our FTC teams. So first off, consistency is is one of the most important factors in competitive robotics. So whether you're talking about mechanical design, wiring, programming, practical habits, consistency is what transforms a good robot into a dependable one. And dependable robots win matches. So today we'll be walking through how each of our teams approaches consistency in our own robots, our code, and our preparation. We'll share our practical examples from our recent seasons to show you how small choices can make a big difference in building a robot that works reliably, match after match. So let's just start off by introducing ourselves. So my name is Lydia, and I am from Team 5485, the Grillbots. So we're a community team from Corning, New York, and our team is made up of members from all ages in high school, so from freshman to senior. And this past year, we qualified for the World Championship by winning the MVVC Utica Regional Championship and achieving second place in Spire. So this was actually our first time going to Worlds since 2016. So it was a totally new experience for all the current people on our team. And at Worlds, we were one of the most consistent teams in the Ochoa division, finishing at the number one spot as the number one alliance captain.
Hi, we're the Silver Wolves, and we're a school team from Kennett Square, Pennsylvania. Our team is made up of rising juniors and seniors. We began as an FLL Challenge team in 2016, and this past season we qualified for the World Championships by winning first place in Spire and winning Alliance Captain at PA States. And then at Worlds we achieved the second highest teleop specimen OPR in Ochoa, with the help of our cool hats, of course.
Yes, and my name is Jason, and I'm part of 21689 Team Tesseract, a community team from Nashua, New Hampshire. Our team is made up of rising sophomores and juniors, and this past season we qualified for the World Championships by winning the New Hampshire State Championship and achieving second place in Spire Award. At Worlds, we were one of the most consistent teams in the Ochoa division, finishing with the fifth highest tiebreaker. We were honored to join the number one alliance alongside GorillaBots and Silver Wolves. A lot of people hear the word consistency and immediately think, oh, it just means doing the same thing over and over. But in FTC, that's not the full picture. Repeating the same result doesn't mean much if it only works when the stars align. If your code breaks under pressure, if your robot jams halfway through auto, or if you miss a match because your wiring came loose. Let's challenge that idea. FTC consistency is not about repeating scores. It's about building a robot and a system that can survive the real world.
So consistency in FTC is all about intentional design. So it's the idea that from the very beginning, your robot, your software, your testing routines, and even how your team works together are all built with reliability in mind. So you don't just cross your fingers and hope things go well at a competition. You build a system that you know will keep working. This includes the physical robot, choosing mechanisms that aren't overly fragile or hard to fix. This includes your code, using testing, sensor validation, and fail safes. And it includes your team, with communication, checklists, and good preparation. So consistency is not just robot do same thing. It's robot keeps working until robot keeps working when things go wrong.
And the biggest reason that you should prioritize consistency is to win matches first and foremost. But if your robot fails, you're less likely to win, so that's why consistency is super important. After that, though, one of the other competitive reasons to prioritize consistency is OPR, Offensive Power Rating. OPR is a stat used at many FTC competitions to help rank teams, and it's based on your contribution to alliance scores over time using some behind-the-scenes math. So here's the deal. If your robot scores 80 in one match but breaks and scores 0 in two others, your OPR will be a lot lower than someone who scores 40 to 50 every match. So let's say, for example, you're in 3 matches, Team A scores 80 and then 2-0 matches after that, and Team B consistently scores 45 in 3 matches. OPR doesn't just average your score, it uses matrix math to estimate your consistent contribution across alliances. So in simple terms, Team B will look a lot better to scouts and ranking algorithms because they can be counted on. And the same goes for judges and alliance captains. When you show you've engineered reliability, not just performance, you become a much more valuable partner and a stronger contender for awards.
So today, let's explore consistency. What does it really look like when a robot is designed to be consistent? And how can you make smart choices in design, code, and teamwork that actually make that happen?
So first, let's discuss the key strategies for achieving mechanical consistency. Well, first, it's important to understand that a simple design executed well is almost always better than a complicated one that is poorly executed. Testing designs early helps identify failure points before competitions, which allows us to make adjustments proactively. Additionally, using external sensors such as limit switches helps ensure consistent behavior by providing reliable feedback instead of relying on guesswork. So for our team specifically, we also always try to print extra 3D parts in advance, especially components that are likely to break. So we always have spares at the ready when needed. And when possible, we also try to use commercial off the shelf components because they're standardized, tested, and usually more reliable than custom parts. Also, one critical point to avoid is making drastic changes to the robot's design and close to competitions. So, last minute changes often introduce new problems to your system that you just weren't prepared for. And finally, we also like to emphasize the importance of protecting vulnerable parts on the robot, like servos, with guards or shields to prevent damage or during matches.
Now, let's look at some examples from all three of our teams, starting off with Tesseract. Over the past few seasons, we broke a lot of servos and realized the biggest issue was driving mechanisms directly off the servo shaft. That almost always leads to failure unless the system is completely protected and low load, like a drone launcher or PTO. To fix this, we tried using belts and gears to offload the stress, but they added weight, took up space, and were more complex than we wanted. What ended up working best was servo blocks. These support the servo's output shaft with a bearing, which keeps things compact while protecting the servo's internal gears. The other big improvement we made was in pattern integration. We started designing parts that follow our build system's mounting pattern, like GoBuilda or Rev, and made sure parts could be adjusted slightly without needing a full redesign. Just shifting something a couple millimeters can make a huge difference in how well things line up and perform. Taking the extra time to build in that flexibility has made our robot much more consistent, modular, and easier to iterate on.
One of the biggest things that we emphasize is that you need to know when and when not to 3D print. While 3D printing is excellent for prototyping and creating specialized low-stress parts, it's usually not the best choice for parts under constant or heavy load. We made deliberate decisions this year to limit the use of 3D printed parts and mechanisms that needed to withstand repeated stress, such as our specimen mechanism, which we rammed into the chambers every time we scored. This helped reduce the risk of mechanical failures during competition. The second thing we would like to emphasize is the importance of planning for sensors early on in the design process. Sensors play a huge role in reducing driver mental load and making mechanisms more reliable. If sensor integration isn't considered during the design phase, it can be more challenging to implement later. For example, during the power play season, we tried to create a distance sensor autoclaw to detect the cone and close the claw automatically. However, there was a lot of noise in the sensors, so the algorithm wasn't accurate enough to use in competition. We realized that if we had a downwards facing sensor to see when the cone entered the claw, we might have been able to compete with it, but at that point, it was too late. By planning materials and sensors before ordering the robot parts, we build robots that are more durable, reliable, and ultimately more consistent in competition.
Intake arm is a prime example of prioritizing a simple and consistent mechanism over a faster, more complex design. Originally, we planned to upgrade our intake arm to a coaxial belted differential arm. However, because of its more complicated nature, it also had an increased chance of failure during a match. This paired with a lack of time to properly test and implement it, which meant a potentially inconsistent mechanism. Instead, we opted to switch to a much more simplistic overdrive arm that was much more familiar and more predictable in a match for our team. Similarly, our design for the hang followed a similar principle. Wanting to ensure our hang would never fail during a match, our hang was powered solely by 3 lift motors rather than a PTO design due to their less consistent nature. Choices like these helped us optimize our robots, minimize risk of subsystem failure, thus maintaining a more predictable performance in a match.
One of the most overlooked but absolutely critical aspects of building a consistent FTC robot is wiring. It doesn't matter how good your mechanism or software is if a loose wire causes your robot to shut down in the middle of a match. Planning your wire layout as part of your design process helps you avoid situations where wires are tangled, under strain, or routed in places where they'll get damaged during gameplay. Poor wire management can lead to wires popping out, ESD issues, or control hubs getting worn out unnecessarily. Looking at some examples, our team learned this the hard way. Early in the season, we didn't think much about the placement of our servo wires, and some of them wiggled loose or got bent too often. Eventually, we had to replace multiple control hubs due to broken servo ports. That was not fun. We also ran into issues with unlabeled wires, overly long cables, and hard to access ports. All of that made maintenance stressful and slow. Later in the season, we switched to using soft cable sheaths for easy subsystems like our deposit, which kept the wires bundled neatly while still making them easy to swap or adjust. The soft sleeving was also much safer to work with, less chance of poking yourself with wire tips or zip ties. Our final tip, label everything and use plenty of zip ties or Velcro to anchor wires down, and make sure they're not under tension when your arm or slides move.
Early in the season, we had major issues with electrostatic discharge causing robot disconnects during matches. We lost in playoffs at a qualifier because of it, and so we decided that we had to make our wiring more consistent and reliable. How did we do it? First, we added ferrite chokes to wires that carry signals like USB, encoder, and servo wires. These block high-frequency interference that can cause disconnects, especially when contacting other metal sources. Next, we focused on electrical isolation. We tested which parts were electrically connected by probing them with a multimeter in resistance mode. Metal parts can store static if they're not grounded, which can contribute to disconnects and damage electronics as large discharges can build up over time. We made sure all exposed metal was connected to the rest of the robot. Finally, we mounted all of our hubs and important sensors on non-conductive plastic to prevent discharges through the mounting points. Since making these changes, we haven't had any more major ESD-related failures in competition.
For season, wiring played a crucial role. Initially, we wired the robot, we focused more on bundling them together against a larger plate. This meant different voltage wires would be bundled together and could interfere with the signal being transmitted in a higher gauge. So, more sensitive signal wires. We also didn't provide enough slack in some areas, meaning some servos would randomly disconnect or the whole robot would lose power. Following our second qualifier, we completely redid our wiring, following some basic principles that reduces these issues. Firstly, we separated different kinds of wires, such as signals from motor wires, where wires must cross, keep them perpendicular to each other, which reduces the area of electromagnetic interference that can occur, which gives us enough slack to the wires near moving parts and reduce contact with large metal plates to reduce the effect of static on wires. This let us drastically reduce how many electrical issues we faced and run constantly for several days without any disconnects, even at very low powers, around like 5.6 volts.
The next step in consistency is your programming. So here are some general programming tips that you can apply to both auto and teleop. Write important values to robot logs and always take a video when you're running the robot. That way, if there's a problem, you can go back and analyze it to figure out what it was instead of just guessing based on what you remember seeing. Most importantly, you should test a lot, and if something goes wrong, don't write it off as just a one-off error, and do your best to fix it. Sometimes there are those weird, bizarre errors that only happen once that you can't diagnose or fix, but most of the time, the problem is both potentially repetitive and fixable. You should also try to finish building and wiring early enough that your programmers have the time to work, because the more time they have, the better their results will be, because they'll have time to do good work and then actually test it. And what you can realistically accomplish varies with what you know, your experience, and the time you have to do it in. So it's good to go for easier intermediate steps first so that you have something working. And if you try for something really ambitious, have a backup so you can switch back to it if it doesn't work. For autonomous, you can use odometry, sensors, and computer vision for tasks that need precision. And that way you can correct for minor variations in the robot or field that might otherwise make your autonomous fail. You should test a lot and keep track of what goes wrong so you can see if you have any errors that happen consistently that you might be able to fix. If it's possible, it's good to be able to run your autonomous on other fields, like by scrimmaging with other teams in your area, for example. You want an auto that will work on any field, not just your own. And you should try not to make too many changes to your program too late. Ideally, any change should be retested with the same amount of rigor that your earlier program got. And it's better to have a lower maximum and hit it every time than to try for something really high but have a chance of failing. Because a lot of that time, that small chance of failure ends up hitting you in the place where you really need it. But the exception here is sometimes you're able to add an extra scoring attempt, like if you have extra time and you're autonomous, without messing up your previous actions. That's good and you should go for it because you're not going to lose anything. But otherwise, it's good to consider reliability of something lower scoring. And in TeleUp, you should use specific automations if they perform better than a well-practiced driver. So it's usually a no-brainer to automate sequences like, for example, flipping an arm, rotating a wrist, and opening a claw at the same time. But only some game tasks are really good to automate, so you should think about it carefully before going all in with automation. You should also run full practice matches because issues might come up during your later parts of TeleUp due to ESD or battery voltage that you wouldn't see if you only drove the robot for shorter times.
In FTC, it's easy to get caught up in fancy solutions, like using April tags or distance sensors for alignment. But when consistency matters, simplicity usually wins. During Into the Deep, Tesseract wanted our robot to align perfectly to the chamber when placing specimens. Instead of relying on sensors, we just set the drivetrain motors to run forward for a fixed amount of time. That one line of code worked nearly every match. It was fast, reliable, and didn't break if lighting changed or something bumped the sensor. Simplicity also reduces points of failure and gives you more time to focus on what really needs complexity. You don't even have to wait until your robot is fully built to write meaningful code. We start early by planning out our autonomous paths, writing the skeleton of our state machine, and even setting up our PID logic before hardware is ready. This saved us a ton of time last season. Once the robot was built, we didn't have to scramble to write code from scratch. We just mapped the logic to real hardware and tuned from there. If you know roughly what mechanisms you're going to have, you can start coding and even test logic with mock values. That way, your first full test isn't also your first time writing code.
So for Silver Wolves, at Worlds this year, we switched from running our 6 specimen auto, which had failed in the couple matches that we ran it in, to our backup 5 specimen auto, which we had run at the state championship. This improved our performance because it worked much better than the 6 specimen. We were able to have such a consistent autonomous that worked so well because we tested it so many times, both during driver practice and individually under different conditions, like on both sides of our field.
So next, we'll explain how we approach programming with consistency in mind. So first, we focused on building in program overrides. So this includes automatic timeout for autonomous movement, manual driver controls for overriding unexpected behavior, and try-catch blocks in our code to greasily handle errors when they occur. These measurements make sure our robot doesn't get stuck or fail just because something small went wrong. Secondly, we use object-oriented programming principles to keep our code clean and organized. We compartmentalize our code into classes, state machine, and commands. This structure ensures that unrelated parts of the robot don't accidentally interfere with one another's operation. For example, our intake logic won't accidentally affect our lift or our drivetrain, or drive systems. Finally, we prioritize writing our own code over relying on complex external libraries. This makes debugging much faster because we understand every line of code we're running. If something breaks, we can fix it ourselves instead of hunting through someone else's framework. All these practices contribute to our overall consistency on the field by reducing unexpected failures in our software. Additionally, we also want to talk about just the good old testing and practice. So testing and practice is where consistency is truly built and proven. There's no substitute for practice. Consistent repetition in a variety of conditions helps both the robot and the driver become reliable. Participating in scrimmages with other teams exposes us to real-world unpredictability that we can't fully replicate in isolated practice sessions. It's also important not to focus solely on autonomous routines. While they're important, you also need to run full matches to build driver habits and reinforce consistency throughout every phase of the game. We also plan ahead for potential failures, whether mechanical, electrical, or software related, so the drivers and team know how to adapt when things go wrong. Starting early with testing allows us to minimize risky changes as competitions approach, which supports overall consistency. Additionally, our team lives by the philosophy that while a typical team practices until they get it right once, a great team practices until it's impossible to get it wrong.
Now, to wrap everything up, everything we've shared today boils down to one key message. Consistency isn't just a characteristic, it's a mindset. We've walked through how our teams approach consistency across the board in mechanical design, wiring, programming, and team systems. We've shown how small, intentional decisions can add up to a robot and a team that performs reliably even under pressure. It's not about chasing perfect scores or building the most complex robot. It's about creating something that works every match with predictable behavior, easy fixes, and enough margin for when things go wrong, because they will. Whether it's printing spares, organizing your cables, logging your robot's behavior, or just having a plan B, consistency means being prepared. It's what turns potential into performance. So as you head back to your teams, we hope you leave this workshop with not just tips or ideas, but with a framework for thinking. Ask yourself, what can we do now that will still be working for us at our next competition? Because in FTC, the teams that win are the ones that keep showing up, match after match, with a robot that just works. Now, let's move on to the question and answer period.
Thank you guys so much for your attention throughout this presentation. And this final slide provides our contact info for all the teams involved, the GorillaBots, Silverwolves, and Team Tesseract. So if you'd like to follow up with any questions after the meeting, collaborate, or share ideas, please don't hesitate to reach out through the emails or social media links provided. And at this point, we'd be happy to answer any questions you have about mechanical design, wiring practices, programming strategies, or how we structure our testing routines, or really anything else related to robotics or consistency. And we're glad to share more insights from our experiences. So we're going to start with some of the questions that we received through the form we posted. Who wants to take the first one?
If you have additional questions now, you can put them in the chat and we'll try and answer them.
And you guys should be able to use the main chat now. I enabled that.
All right, so the first question was, we're a rookie team, so what would your advice and resources to have a good robot design and also for programming? I mean, oh yeah, go ahead.
Sorry. So during this webinar, we talked a lot about simplicity, and that's even more important for a rookie team. As a rookie team, you're learning and figuring out a lot of new things, so it's okay to go with something that's simple. I know Silverwolves, our first year in FTC, we took a go build a strafer chassis and slapped a go build a cascading lift kit on top of it, and then a claw where one side moved, and that was our robot, and it did pretty well because we tried to keep it to what we knew we could do and understand. And then we improved over our future seasons, but both our mechanical and our programming were simple.
I'd also say, like, as a rookie team, I wouldn't feel afraid to reach out to other existing teams, also just look at what they've been doing, like watch videos of their matches, like watch tutorials that they might have, like attend things like this where a teams like us will be giving advice out, and always feel free to ask questions or DM us or email us. Like, we're not scary guys. Like, it's totally okay to reach out to us with any questions you guys might have.
Yeah, and for some more specific resources, I can share a couple. So Game Manual Zero is great for both programming and mechanical. They have a lot of stuff about driving code and how mechanism force vectors work, and some more advanced stuff there as well. And then FTC Tech Toolbox is also a great one, especially for programming. It has a lot of stuff with vision and kind of getting you introduced to that. And for maybe larger teams or teams that are starting out with only one control hub or not too many resources to build things up and test them out, there's also FTC Sim for programming, so you can test things out and have programmers practice before there's a robot available to do it with. So those are just some of the resources I thought of off the top of my head that have been helpful to me and others. All right, so the next question that we got pre-submitted through the forum is, how do you keep your vision and your autonomous constant?
Yeah, so I can talk about that one a little. For vision, one of the big things is we talked about having your robot log certain sensor values. You can access them, but you can actually also save off the frame that your camera is seeing to the control hub, and that way you can plug a laptop in and pull off the image later, and then you can actually just run it through reprocessing your code to see, okay, what exactly was the robot going off of at the time it made this decision, because otherwise you're just guessing about the cause of the problem. So I'd say save off images at important points so you can retest them later. And for autonomous, I'd say try and figure out where sensors can be effective. Like, for example, if there's something that you need to be a certain distance from the wall to succeed, then use distance sensors on the wall. And like we said, those should be planned in early on so that they can be the most effective.
Yeah, and one of my tips for using vision in autonomous is don't start right away with vision. So at the beginning of this season, my team started straight off trying to do different AI pipelines and OpenCV things to detect samples, but we never actually got to use that until right before Worlds, and at that point we actually did decide to not use it at Worlds to ensure a more consistent sample auto. So I would definitely focus on getting your autonomous framework, your first autonomous done that maxes out everything that you can do without needing vision before you go and implement it.
And just like to reiterate again, especially in terms of programming, whenever you change something new or add anything on, it's really great to just test everything out as much as possible. Because like sometimes things will just happen that go on in your program, and it's really great to just be able to identify those and stamp them out early on before you guys get to competition, just so you're prepared for everything that might possibly happen in your code.
Yep, and just to check quickly, do you guys have access to chat? If you do, could someone just send something? I'm just trying to make sure. And then we can go to the last question that we got pre-submitted while we're waiting on that. And if anyone has any questions, feel free to put them in chat. And so the last question that we got pre-submitted was, did you guys get Inspire at all? And if so, what did you guys do to get it with the robot and outreach?
Yeah, sure. So I can take that one. So at our state championships this year, all three of our teams won Inspire Award, both first place and second. And one of the largest things we did with our outreach to contribute to that was ensuring consistency there, ironically. So a lot of teams do one-time events, one-time workshops, seminars, that kind of thing. And if you do that, that can be great, but it often looks better, the judges, if you have like continuities of everything and you can just show that you're engaging with the community over time. So, for example, last year my team hosted a 3D printing workshop where we taught a bunch of people how to 3D print using some 3D printers that we brought. And that's great. And this year we're expanding it, not by doing a bunch of new events, not by spinning it off and doing a programming workshop, a design workshop, but we are just going to be doing that 3D printing workshop multiple times throughout the course of the season, such that people can be impacted it and it just looks a lot better to the judges.
I think that's definitely true. I mean, it while it is like also good to like include some new things and like get first out to different areas, just those relationships you build over time in the community are also just really great for those people too. Like for us, we have several relationships in our community with like local science organizations, where we like come in and give like a robot demonstration or just share a little bit about the first program and who we are as a team. So like those relationships that you build over time are really crucial for those people and yourself. It's just really rewarding to see how like these organizations or things you go to just like kind of build over time, and it's really impactful for us as well.
Yeah, and
So
this
in terms of, sorry,
go
in
ahead, Kate.
terms of the technical content in the portfolio, it's important to document everything you're doing all season. And it's not always the greatest thing. Like you want to be doing obviously all the technical stuff and building things and prototyping, but you also want to be documenting because when the time comes around to write up the portfolio, you're not going to remember everything you did. So good documentation leads to a good portfolio. And I'd say like just in the process of getting your robot working, you're going to have done a lot of iterations, and that's the engineering design process. You don't think while you're doing it, ah, yes, I am doing the engineering design process, but you are, so make sure to include all that because you should get credit for all the work you did.
Yeah, so now let's move on. I see some of you guys ask questions in the chat. I love it. If you guys have any more, please feel free. So the first question that we have is from Lauren. How much did you dedicate to driver practice to support consistency in robot performance?
I
would
can
like to
talk
start.
a little bit about that one. Generally, in the weeks leading up to our competitions, and even before, like 3 weeks before the competition, we would just dedicate all of our meetings to practice. My team meets 8 hours a week, so that was 8 hours a week for 3 weeks of just practice, running full matches, running autonomous, running teleop, figuring out, okay, what are the little things in our strategy that we should tweak to make sure we're really maximizing the score we can get, while also making sure that we can achieve that score consistently.
And it's
Yeah, and I
also like even oh, sorry, go ahead.
okay. So for us, the other big thing is when we're doing all that practice, we just have a big Google sheet where we put the scores for every match. So like autonomous and teleop, specimen sample if you're kind of like a both team, and then just a notes column where you note down any big changes that you made to the robot or to your strategy before each match. Well, before the match that you practice with them. And then you can look back and see how those changes affected your driver practice positively or negatively, so you can figure out how to adapt your strategy going forward. And it's also really good portfolio content after that.
That is a really good strategy, actually. I was just gonna remind people again to, like in the beginning, when you're first starting out by building your robot and programming, it's really important to have the building of the robot locked in, like pretty early on, because you don't want to just like put it on at the last second. The programmers have like a week to program the robot before your first competition. Like that is really bad and just like kind of not a great strategy. So it's important to like make a checklist of like maybe like certain goals you want to meet. Like we should have the drivetrain done at this time or this date. We should have the intake is like put on at this point. Like you should make those goals for you laid out in like a timeline and try to meet those goals. To just make sure you finish things on time and don't push things off to the last second, because it's really, I mean, because you might have a really greatly designed and built robot, but it's not programmed right, or it isn't programmed fully. So you're like a push bot at the competition, and you just never want that to happen, especially when you've put so much work and time into building a great robot. So just try to keep things simple and minimize like the huge complicated designs until maybe a little bit afterwards.
Yeah, and
So,
oh sorry. I definitely agree with Silverwolves and Gorillabots here that it's really important to lock all the changes before the competition. Like for example, my team, as a rule of thumb, 2 weeks before every competition, we just stop making any physical changes and we try to make as little programming changes as possible, especially with tuning auto, because if you have an auto that is just about there and there's just weird issues sometimes, that's field specific and you're going to have to do that tuning anyways at competition. So don't waste your time doing it now. And then the other thing that my team does is we just drive throughout the entire season, even when the robot is just a drivetrain, even when there's no scoring action, because it allows us to kind of get a feel for how does the robot move, and it's just a little easier for us to start off with something when we're doing big rounds of practicing.
All right.
All right,
So,
great. So, oh, I was gonna move on to the next
sorry.
question, but jump in with
Yeah, so was
anything.
I. So you go
Oh,
ahead.
okay. So we have, other than laying out code and pre-planning code, what does software do while waiting for the robot to be built and tested?
Yeah, so I can take that one. Sort of by the nature of how things work, you're gonna like front load your mechanical crunch time and back load your programming crunch time. But while they're waiting for the robot to be built, there's still plenty you can do. So you mentioned planning and laying out code, and those are really good things to do. But there's other things you can do, and some of this depends on what resources you have. So for example, if you have like a robot from the past year that's intact, you can work on like movement stuff or things you've been wanting to try out. I mean, of course, that means you need to have enough parts and control hubs to have that robot still around. But even if you don't, one big thing you can do is get Vision up and running. All you need to do Vision is your control hub that you can plug a webcam into. So even if you're, holding the webcam and just moving it around to simulate different positions, you can start testing out computer vision even
Yeah,
when your robot's still being built.
Yeah, I definitely agree with Katie here that there is still things you can do well after you've laid out and pre-planned your code, especially testing vision and those things that are a little further off in the future, but you can kind of start those now. And then this is kind of specific to how your team is structured. But for example, on my team, portfolio is something that we do most of it in the off season, but during the in season, if someone doesn't have something to do, go work on the portfolio. So figuring out what tasks like just need to be done. Like it's always very useful to have people that are versatile and can just work on whatever's needed.
I definitely gotta agree with Jason on this. So something we also do on our team is like if you have any free time, like there's always something to do. To always ask. So it can be like making the team pins. Like it could really be like almost anything, but it's like it's really important. Like while you're in like during at a meeting, you don't just like waste time on your phone or just like socializing. It's important to use like every minute of time you have there to just do whatever you can to help the team. So it can really be like anything small, like making a pin or like writing a documentation thing. Like it really doesn't matter. It's just trying to do whatever you can to help your team succeed.
And I also think that for us, kind of like coherence between programming and mechanical is super important. So obviously the programming people aren't going to be there for like all of the super technical mechanical discussions, but for some of the higher level brainstorming, sometimes it helps to get different perspectives of like what programmers think of the game and how that kind of mindset also shifts like kind of those ideas going forward, and how programmers might think programming or automations that might be necessary fit into those mechanical designs that are being planned, especially with like automations. For example, if you're doing like a claw in the submersible or something and you think, oh, it's going to have to require a lot of precision, so maybe we want to add some vision to that, then the programmers can start looking into that before the robot is necessarily ready for that state. But they can do all that research ahead of time.
Yeah,
So
your
I think
programmers
that's
should definitely be having design input because you might say, "Oh, there's like a potential problem for this design, but we can fix it in software." And sometimes your programmers will go, "Yeah, sure, we can do that." And sometimes your programmers will go, "No, that isn't going to work. We need to change this design." So it's really important instead of viewing build and mechanical and versus programming as like two completely separate things. They really need to work together
Yeah,
to design the best robot.
And on a similar note to Katie, you also want to have great communication between your programmers and your drive team. At least for my team, it helps because I am programming and drive team. But talking with the drivers and saying, does the robot feel weird? Is there something like new functionality they wish you had, or is there just something you wish you could tune? Getting that input is so valuable, and it can really help change the performance in the match. So, for example, this year, one of the other drivers from my team said that it seems like he had to reduce the speed when he was driving because the robot had a higher tendency to tip. So I was like, what can we do about that? And I ended up writing logic that used the IMU and some acceleration stuff on the robot to detect when it was making sudden changes or had like risk of tipping at high speeds. And then it compensated for it automatically. So there wasn't any tippage after we added that.
And I think another important part there is talk to the drivers about what you if you're doing two drivers, what you think each driver should be doing. Because I know one thing that we try to do is kind of reduce that mind meld that's required between the two drivers, because you want to be thinking the same thing, but you don't want your whole driving strategy to be dependent on both drivers knowing exactly what the other is about to do at the same time. So, like, for example, if the driver one that's moving the robot around stops for a second and driver two closes a claw or something, but driver one was actually about to make another adjustment and then it messes up that pickup, you want to try to avoid that. So maybe putting some of those things that require knowing when the robot's going to stop moving also on driver one, so that it's not like driver two has to ask out loud or know exactly when the robot's stopping, and then also figuring out what those things are that can go on driver two to reduce the mental load of driver one.
Yeah, so our team also has like two ways we try to address that. Is one, we try to automate as many things as possible during the teleop program for our drivers. So like our program will have automated, so they can just like press one button and like the arm will extend and the arm will come back. Like it's pretty much automated most of the functions, so it's really easy for the drivers to complete the functions in the during the game. And second is just a ton of driver practice. Like it's also the robot, but it also comes down to like the chemistry of the drivers with the robot. So just doing as much practice as you can with the drivers and the robot to just get a feel of how things work is really important, which is what like Jason and Lincoln and Katie were talking about. So just like getting as much practice as you can possibly can.
Yep.
And we can move on to sorry. Go ahead.
So I think we were both about to say the same thing. So our next question that we saw in the chat was, how do you suggest you build relationships with other teams? And I can start off here. You just have to reach out. No, there's very few teams that are going to say no. So for example, I'm just thinking of off the top of my head, what teams did Tesseract meet with this season? I'm thinking of Indubitables, Bluebot Builders, Robo Players, Robo Kings Aurum, and all of these teams we still maintain contact with. Like, for example, I was talking with someone from RoboKings earlier today, and it's just such a valuable experience, especially when you're picking top teams to look at, because they give you more advice than like you even came in for. So for example, for my meeting with RoboKings Oram, I was asking about some things for active intake design. And Tinko from RoboKings actually ended up giving some advice for kickoff as well, which was for all of our plates, adding the pattern directly into there, which allows us to mount things and not have to worry about doing full design to prototype. So you always get more than you come in asking for. So definitely just reach out.
Yeah, and I'd say like more locally, just talk to teams at competitions. If you see someone who has a cool feature on their robot or in their programming and you wonder how they did that, ask them. Most of the time they'll be really excited to tell you about how they made that work.
Yeah, I know, like,
So,
coming into robotics, I kind of assumed that a lot of teams wouldn't want to share, like, exactly how they did something to make their robot, like, more consistent on the field for a specific season or something like that. But my experience the whole time I've been in FTC is just people really actually do want to share and help out and give back to the community and help you learn kind of what they've been through and what they've learned from their experiences there. So don't think the teams are scary or too hard to talk to. You can reach out to them on social media. If you can find them on Instagram, DM them. And also the FTC Discord is a really good place to find teams as well. Ask general questions in the channels and then maybe see if teams are willing to mentor you or something like that from there as well. Anyone else have any thoughts for that one? No?
Other
Also just like,
strategies
oh yeah, go ahead,
at
Andrew.
local competitions is a good time to talk to other teams is actually like before the competition starts when teams are setting up, because once the competition gets going, like the senior people on the team are probably going to be busy, so it's good to go right before the competition begins.
Yep, definitely. Lydia, did you have
all right.
something to add there?
No, that was actually
No.
exactly what I was gonna say. Really funny.
So our last question that we have here in the chat is, what kind of data have we collected for robot development? So I think this means like what kind of data do you keep about your robot to see what you can improve? And for us, like we mentioned, that's keeping track of our scores in every practice match so we can see general trends like, oh, we tried this new thing, it made our score go up or down, for example.
Yeah, my team definitely does the same thing, especially when we were practicing and like we started consistently getting over 200 solo. We started like recording everything, but one thing that I think personally is amazing to collect is just like it sounds like something you do for an award, but it is very helpful is finding a metric and tracking it throughout the season. Like it could be points per match like we talked about. It could be auto points or something else. But it's just you just need to find something that works for you and then just commit to it so you can keep tracking.
And I think for us too, we also try to like isolate certain aspects of our robot, like the intake or the outtake, and test certain things that might be causing us some trouble. Like for example, like we did a lot of intake testing this season, just because we were having problems deciding what kind of design we were trying to go for. So we did a lot of design on how it would clamp down on the sample and like how it would move and react to our program. So with that, we were able to consolidate on like a specific design for our intake. So just doing those kinds of things and like trying to keep track of that data by figuring out what the best thing is for your robot.
Yeah, and I think throughout this whole presentation, we've talked a lot about planning and a lot about thinking of these things, but just remember that you can spend all the time you want planning, but you really do have to execute. So think about it for a few days at the start of the season, but then just commit to something and start building. And it always helps to look at what other teams have done in the past. So, for example, my team at the beginning of the season, we had two designs this season. We started off with like a pitching linear slide, but we didn't think about it as much as we should have, and we didn't do as much CAD as we should have. And the design that we ended up going through with only had one linear slide that was pitching, so it had a lot of slop in there. But if we had looked at other teams that had done pitching slides in the past, we could have kind of figured out that, oh, you shouldn't do that.
And that's definitely a great point. So just moving on to the next question that we got. Since getting alliance team is purely based on luck during competitions, how do we deal with poor alliance teams and still win target? I think that's a really good question, actually. And just like to start it off, I think just focusing on yourself. Like sometimes in matches, they're just things that are going to be out of your control. Like if you receive an alliance partner who's like a little bit of a poor alliance team, it's just trying to stay consistent yourself. Like there's only so much you can do. You can only control so much of like how they're gonna perform in the match. So it's just controlling how much you can do. And part of that is being a consistent team and ensuring that your performance is going to be steady and solid in that upcoming match.
Right, definitely. And
Yeah.
I think when you do that, you can find those creative ways to pitch yourself to other teams when alliance selection comes up. Like especially OPR, it can be dependent on your alliance's total score, but it's also very dependent on how much you contribute to that score. So that kind of has some margin of error for those partners that are randomly assigned. And just being able to know how to market yourself and just realizing that you're the team that the alliance partners are going to be looking for in elims and not the other teams that you were paired with. So for example, at Worlds we kind of got a schedule where we were paired with, so we were a specimen only team, and we got a schedule where we kind of got paired with some other specimen only teams in qualification matches, and it was a little bit hard to perform super well in those matches. So we were happy with how we performed by ourselves, but I think our record ended up being like 2 wins, 3 losses, or no, it was something like that, something around
Yeah,
there.
so
Yeah, so just we still got selected for the number one alliance, and it was because we knew that we were performing the best that we wanted to perform, and we just stayed confident in that and showed that to potential partners.
really
Yeah,
like on the
so
other side of that, like one of the reasons we picked Silver Wolves during was because we saw them as a consistently strong team throughout their matches. So even though they were faced with some challenges in their pairings, we were able to see past like the final score, and just realize that they were a very strong consistent team. Same with Team Tesseract. Like it's like we teams will look at that data and will look at your OPR and still look at your performances. So like if something happens and does are wrong, I wouldn't like be all down like blame like people good teams will still look at your overall performance, so I wouldn't count yourself out just because of something that might happen that's beyond your control.
A
yeah,
Yeah.
and I'd
strategy
say
that a
sorry.
strategy that we use on Gorilla Bots is we're always looking like 3 to 4 matches ahead. So we're seeing who we're going against and how strong they are, and who we're going against them with, and we're talking to them like matches before to just form a really strong strategy.
Yeah.
Yeah, and I'd say just for any match, no matter how bad it might look going in, like if you're against two really good teams and you have a partner whose strategy just doesn't mesh with yours, like don't write yourself off any match because if you go into it thinking, ah, this is it, we're doomed, we're 100% going to lose, that kind of gets in your head and it might make you perform worse. So just give your best in every match and you might win, you might lose, but even if you lose, you've put up a good performance for yourself and sort of lived up to your potential.
Yeah, and I have two things. So the first one is specifically about targeting that win, which is in a match. So for example, at Worlds this year, my team was with another team that said that they had a 5 specimen autonomous, and they were actually getting it quite consistently at the practice field. So there wasn't much we could have known. But in the actual match, they ended up only getting 1 or 2, whereas we ran our 4 sample auto. So it would have been more advantageous for us, and it could have changed the outcome of the match potentially if we had targeted a lower theoretical auto score, but we had run our 5 spec, which worked every single match. So I definitely think about that. And then the other thing is teams will notice you in playoffs, but you do need to go get yourself noticed. Like, for example, at Worlds, I went around and well, all of my team went around really, and we talked to almost every team that was in a picking position in our division. And I think we talked with you, Lydia,
Yeah.
but we didn't have any idea we were going to get picked. We got to the end of the alliance selection, we were like, this is questionable. But it's definitely a lot about just what's going to happen is going to happen. Think about how you can maximize your score. And at the end of the day, even if you don't win, if you did your best, that looks good for alliance selection.
And just in general, like even if you don't get pet, if you did your best, I mean I'd still feel satisfied with myself. Like we put everything out there, we tried our best to communicate with the teams. So there's only so much you can do for that, and I just feel like be at peace with yourself. Like I think it's all good, and in the end, like you can still stay to watch the matches. In the end, it's like it's for fun, guys. Like we're all here to have fun and like all collectively succeed together. So.
All right, looks like we have one last question here about how do you balance academics with FTC and how many hours do you work? So yeah,
That's
it is.
definitely
It's
it's
tough.
definitely kind of a personal question. And it depends a lot on the specific person that is doing all this. But I can give the example for myself. I commit to FTC. Almost do no other extracurriculars during the FTC season. And I will go from school, I will drive myself to the house that we meet at, and I will sit there for like 6 or 7 hours a day, and I will work on robotics. I will go home and I will sleep. But that's not feasible for a lot of people, especially if you have more extracurriculars or you need more time to do your homework, if you can't get it all done during school itself. So it really does depend on the person. But for me, at least, if you prioritize robotics over other activities, you will find more time to commit to it.
Yeah, and I'd say like again back to consistency. Putting in a little bit of work consistently every week is better than trying to do a whole ton of work and then burning yourself out. So just be aware of your limits. If you say, "Oh goodness, I have like 3 big tests tomorrow. I can't come to like I need to focus on studying for those. I can't do extra work," then that's okay. Like
Yeah.
it's really personal how to strike a balance between still doing well in your academics and your other extracurriculars and putting the time that you want to into robotics. And in terms of how many hours you work or how many hours your team meets, honestly, that has a lot to do with what your team's goal is. If you say, oh, our goal is to get to Worlds, then you might need to put in more time for that. Like our team meets 8 hours a week, plus programmers work outside of that and will sometimes have extra meetings for driver practice. But if your goal is to like, oh, we want to go to our qualifier, to our league meets and just have a good time, that's just as valid a goal and you don't need quite that much time for it. So I'd say just talk it over with your team, figure out what meeting schedule and intensity works for you guys.
Yeah, and I almost kind of want to take this a different direction, kind of building off what everyone else said and what Lydia said for the last question. Robotics should be fun, and I know for Silver Wolves, one of the big things that we do is just like emphasizing the teamwork and just the collaboration between everyone and enjoying each other's company and just working together to get to that final product. Obviously you want to perform well and you want to do the best that you can at competitions, but it's really not worth too much if you're not enjoying it all along the way and learning yourselves. So just have fun and talk to your teammates. And if you have something coming up, you can coordinate with them and figure out how to shift work and just figure out what works best for your team and everyone individually, because it's a team. It's not just individual people, and you don't always need to be focused on that competition winning. You just need to be focused on doing what you can and being realistic about it.
Yeah, and I have something that kind of builds on yours, Lincoln, as well. But before I say that, just as we have a few minutes left, if you have any remaining questions, please definitely put those in the chat and we will answer those. But it's definitely similar with my team as well, Lincoln. It's important to communicate and it's important to figure out if someone can't do this, it doesn't matter if no one knows. Like you have to delegate tasks and figure out where can like different people work on different things, and it is just building a strong team that everyone can rely on. So focus on meeting and focus on like just delegating tasks. So for example, in this off season, my team is meeting virtually every week and we talk for a few hours and then at the end we assign action items so everyone feels responsible to some part of the overall team and has something to work towards instead of having to overcome the barrier of going and asking and figuring out what can be done.
Yeah, kind of building on that responsibility too. Something that's kind of unique to Silver Wolves is we don't really have captains or captains of any specific team. We kind of operate as more of a democracy. So we have people that are assigned to specific roles, like for example, custom CAD or teleop programming or autonomous programming. And they obviously are the ones that are working on those specific things, so they kind of feel more responsibility for those tasks. And like there's always something to work on, so they're not just sitting there and not sure what other people are doing. But, at the end of the day, we don't make any decisions, just one person making those decisions, big decisions for the team. It's always everyone gets together and we vote on things. It's not like a captain just decides on something. And I think that really helps us to stay motivated too, because it feels like everyone's included in the team and it's more personal to you.
And I kind of want to just give a number for the number of hours. It varies a lot. In like the thick of design and build season, I'm putting in generally, I'd say, at least 30 hours a week. Um, but sometimes that dies down. Like it just kind of depends on how much your team's trying to do, what your budget is. But it can be a lot of time. But I find it totally worth it.
Yeah. And making that time valuable is also important. So it kind of ties back into everything that we've been talking about. If you're a rookie team, or even if you're a more experienced one, go for something simpler to start off with. Go and talk with other teams so you're not figuring something out by yourself and then everything like that. So it's really a lot to determine how many hours you put in.
And then just like at the end of the day, always like it's about having fun together, guys. So again, thank you guys so much for joining our webinar. And if there's any last questions, feel free to send it in. But we are going to end in a couple minutes. So again, just feel free to reach out to any one of us. We'll be happy to have like a one-on-one discussion with any of your teams. And thank you guys so much for attending today.
Yeah, thank you guys.